Hello guys, in this video we will be discussing use of new and delete operators. In the last couple of videos I have discussed pointers, little advanced pointers like array and pointers, structures and pointers. Now another very important concept which we need for unlocking data structure concepts is new and delete operators. Primarily they are associated with memory management. You are aware when we do programming, when we write programs, we need memory. Sometimes we allocate memory statically, sometimes we allocate memory at runtime. So static allocation has some limitations like array, basic array uses static allocation. It has some limitation, falling short of memory when more memory is required because it is allocated at compile time, at runtime we cannot change. And if we allocate more memory, there are chances that we waste memory. Memory is an important resource. It should be handled efficiently in an optimal way. That's why runtime management of memory comes into picture. For this, C++ language provides these two operators, new and delete operators. New and delete are actually keywords. We make use of them to allocate and deallocate memory. They are very simple operators. New, it is used for allocation of memory at runtime. Delete, it is to free the memory at runtime of the program. How we allocate memory using new? New basically allocates a block of memory, specified number of bytes it allocates, or it will find out depending on the data type that many bytes it allocates and returns address of the start location. Address of that block it returns. Start address of that block it returns. For instance, I'll show you here. Say if I allocate memory here, new int. So this is the way I allocate memory. New int. How many bytes of memory is allocated based on the type? 4 bytes of memory is allocated. So when the memory is allocated here, 4 bytes, say these are the 4 bytes we have. The start address, let's assume the start address is 1000. The next will be 1001, 1002, 1003. This way, these are the 4 locations, 4 bytes of memory allocated, and this start address it returns. When it returns, we must collect it in a pointer variable. Let's say it is a p, then we must declare p as an integer pointer because it is a memory for integer. Similar way, if I would like to allocate memory for an array for n integers, n is available at runtime of the program, so I will be allocating memory for n integers, then it will be 4, n real numbers, double values, n into 8. So it depends on the type, data type. Say if I am using an array, array name is say ARR. For integer I want to allocate memory, new int, and here number of bytes n we have to specify. So for n numbers it will allocate memory. How much memory it allocates? N into 4 bytes, size of integer, and that will be returned to array. That's why we have to allocate array as a pointer, because new returns address, that address we copy in pointer. This is how the new operator we use. You can have a look here. For efficient and optimal use of memory, the program must use runtime memory allocation depending on the requirement, and when it's no more used further, it must be freed. This is the rule of memory management. So what I illustrated, demonstrated, the same thing we find here now. You can see Now similar way, this is what about the built-in data types I have shown: integer, double, and array. Now, if you want to allocate memory for user-defined data types, like we define structures. In this case, I have defined a struct account. Now, if I say account, I can create a variable account A1. So this is a structure variable. The kind of memory allocated to is compile time memory. When this statement gets declared, that time memory will be allocated. That's why it is a static allocation of memory. And how many bytes? Account number integer 4 and balance is double type 8. So 12 bytes of memory is allocated at compile time. Remember. Now if I would like to allocate, I am in need of 12 bytes of memory for a structure variable at runtime. Then I must allocate at runtime. For that, the operator is new account. The data type we have to specify. So new account, it will allocate 12 bytes for the account type, and I will be collecting in it a pointer. Say this is a pointer. Now what type of pointer it should be? In the pointer session I have told you, it should be pointer of type the data you are holding. What kind of data you are holding in this pointer? Address of account you are holding. It is the address account. So address of account, then the pointer type should be account star P. So this way we have to declare. P is account type because P is holding address of account. This is how you have to interpret it. Now you allocated memory successfully at runtime using new. The job of that particular memory block is over now. We must free it. So that we do using delete operator. See here I have done that kind of things. Deallocation, you can say, or freeing the memory. Once the memory is used and when no more it is referred, then it must be deallocated. It should be done by the programmer. If you forget to delete, it will lead to one of the major problem, that is memory leakage. If you don't forget without freeing the memory, if you come out of the program, a hole will be created that leads to segmentation problem and memory leakage. So this is an interview question. So remember what is a memory leakage and how it gets into picture when you allocate memory at runtime and forget to deallocate, free it, and without doing that, if you come out of the program, it leads to memory leakage. There is one more concept, dangling pointer, that when we do these things practically, there I'll show you what is a dangling pointer. Let's now go to the programs. Some one example for array, this one memory allocation for an array we'll see here. See, this is an example for array allocation at runtime, because the number of items to be stored is available at runtime n. C in n we are taking. As per that, it will allocate memory. Since it is allocating memory, see, this is the new operator. This is a new operator. This new operator allocates memory for n integers. So n into 4 bytes it will allocate. The start address it will store in array. Then it will be used like a simple array. Say I have stored here some values and then I am printing it. So let's run it and see. Say enter number of items is 5, 0, 1, 4, 9, 16. These are the items I have stored. Now guys, look at this program now. In my theoretical discussion, I told you that if you, after use of that memory which you allocated at runtime, if you forget to deallocate, if you forget to free, and without deallocating, if you come out, it will lead to memory leakage. Now, I have not freed the memory. Without doing that, I have come out of the program. So this program has a trouble of memory leakage. If it is run n times, it may lead to memory crash. That's why you have to be very careful. Before coming out, you should have a statement like delete the pointer array where you have stored the start address. It will remove all the bytes from start to end which you have allocated using new. Now this is the correct version of the program. So hope this point is clear. Now what is a dangling pointer? That I will demonstrate you now with the example. Let's put this in comment. Now here I have that example for dangling, and I don't know whether it is a dangling pointer or no. We'll ask ChatGPT what will be the response. We'll see. This is the problem statement. I have two pointers here, P and Q. These are two pointers. I am allocating memory at runtime new int for one integer, and that address I'll be putting in P, and then value at P will be 5. Then P is assigned to Q. I am assigning P to Q. Later I accidentally or deliberately I delete P. My job is over, I delete P. But the address of P you have stored in Q. It is still, Q is still alive. Q is still alive. P, the address held by P is no more now because you have said delete P. Then that address is no more valid address, and you are allocating memory from a value from that memory value at Q. So it will create a issue. Let's run it and see. See, now some junk value, garbage value, it is displaying. We are actually supposed to get 5. Say with, I'll not delete now. I'll not delete without deleting. Now P is still alive. Now in this case, what happens? I'm getting the correct answer. But again, still here, memory leakage issue is there because I have not said delete P. I must say delete P, then the program is correct. That we'll do it later. Now this program, it is P. What is P? P is actually when I delete this one. When I delete P, that P is called as a dangling pointer. I asked this question to, I copied this program and I asked this question to ChatGPT. Say, what is the problem in this program? ChatGPT said, this issue in your code is dangling pointer access. So delete P, the memory pointed to by P is released back to the system, but Q is still pointing to the same deleted memory location. So how you can do that? That's not possible. So this is one example of dangling pointer, memory leakage and dangling pointer in interviews. For sure, the interviewers ask. So clearly understand what is a memory leakage. It comes into picture when we do runtime allocation and deallocation, and if we forget to deallocate after use, memory leakage will be there. Dangling pointer, we remove the pointer, we delete the pointer, but somewhere again it is referred, its address is referred, that leads to dangling pointers. These two are negative things, they are not desired. They are very, if your program produces such things, that will lead to memory crashes and program crashes. So take care of these two things and understand it clearly. Hope you got the idea. Thank you.